I'm gonna give you, okay, I'm trying to give all of you an introduction into what ISA is, the International Seabed Authority. The title says within national jurisdiction, so that's actually what we do not cover. But of course, we live we live from our member states, right? And a lot, if not all of the ECOWAS states are member of ISA. So that's why, of course, it's all relevant to our activity. So ISA's legal framework for activities in the area. So we are an autonomous international organization, which was established in 1982 under the UN Nations Convention on the Law of the Sea, UNCLOS, which is considered our base, our book, right? And the 1994 agreement, which actually introduced ISA and introduced also our host country, Jamaica. ISA has regulatory power to develop rules, regulations, and procedures, which is called the Mining Code. In accordance with UNCLOS, all state parties to UNCLOS are ipso facto ISA members. And as of September 2025, 169 member states are part of ISA and the European Union. The area and its resources are the common heritage of humankind, and that's a very first time when a natural good was defined as a common heritage of humankind. And I think that's a very important step, so that no state has appropriation, there's an equitable sharing of benefits, the peaceful use is mandatory, exploitation has, if it happens, it has to happen for the benefit of mankind or humankind. Activities are carried out under a contract with the ISA, and the ISA is a regulator and an administrator of these contracts, but also setting rules for exploration, which are existing, and exploitation, which are under development, and hopefully will be finalized in the year to come. Let's cross fingers. Yeah, so ISA is the organization through which state parties to UNCLOS organize and control all activities related to mineral resources in the area. The area with capital A, it's important, it covers 54% of the total area of the world's oceans. So when you look at a map, you see all the blue. It's usually set out in blue, as you know, right? So 54% does not belong or is not part of any national jurisdiction. This may change because countries can apply for extension of the continent, so-called continental shelf, as you know. But up to now, 54% are forming the area with capital A, and the size is 181.963 million square kilometers. So it's big. And just in front of you, you have the only geologist who's responsible for it. Oh gosh. So it always makes me quite nervous. So yeah, ISA has the mandate to ensure the effective protection of the marine environment as well. So all activities have to, it has to be made sure that all activities effectively protect the marine environment. Of course, when we talk about mining is always extractive, as agriculture is, right? So I'm always saying, if we pull a carrot out of the ground, even if it's an organic carrot, it consumes potassium and fertilizers and so on, like phosphate, which has to be re-fertilized, right? Replenished. So it's extractive, what humans do. But effective protection also means that areas are set aside to make sure that any biodiversity may rehabilitate areas which were under potential mining. As said, there's no mining happening at the moment. There's only exploration. ISA also has responsibilities on marine scientific research, capacity building, which is a very, very key of ISA's doing, and I can use the moment now always to make some to ask anyone if anyone is interested in coming to ISA Secretariat for an internship, or sometimes we have expert deployments. So the conditions always are can be negotiated, right? There are lots of opportunities. So we are always happy to have people like you from developing countries and share our knowledge and to work with you as well, right? Because you're experts. So ISA mandate is manage exploration and potential exploitation, to protect environment and biodiversity, to promote marine scientific research. We are not a research institution. We can only promote, but because we know research institutions, we know, of course, there are contractors. We promote marine scientific research with our contractor and say, well, you need to figure out what you found, right? And of course, there's a benefit sharing eventually as soon as exploitation is starting, so that the monetary flow is or has to be established to at least developing countries. Yes, right. The ISA structure and organs, for those of you who do not know, so we basically have 3 organs, which is the Assembly, as you can imagine, 167 member states, and the European Union for the moment. Maybe in the future there's ECOWAS here as well. There's a council with 36, I think, if I calculated right, 36 member countries, which is basically the legal engine for all decisions by the Assembly. And the council, actually, it has the legal and technical commission, which have a group of 41 expert members. So there are geologists, geophysicists, economists, engineers, marine biologists, of course, right? Oceanographers, and they have the role to answer basically questions coming from the council, because the council is a political organ. And if they want to know about habitats, how rare are marine biological habitats, right? And then the legal and technical commission comes in and say, okay, we provide you with the information you ask for. Another sub-organ would be the Economic Planning Commission, which comes into place as soon as exploitation or mining is starting. It's not existing yet, but ISAs or the council is on its way to develop the TORs for the Economic Planning Commission. And there's also an organ which is called the Enterprise, and that's already in UNCLOS, in the law of the sea. The Enterprise can start exploration, but also exploitation on its own. So it's a sub-organ, if you want so, which is attached to the ISA Secretariat, but can be active in even exploitation and mining eventually by own rights in finding investors and so on. But also the Enterprise has to, as all potential miners, have to provide ISA with a distinct amount or a distinct percentage of their earnings, which is then again going to least developed and developing countries for the benefit of humankind, as said. The Secretariat, we are about 50 people now. Just now, we have a Secretary General and then administrative and technical staff. So the technical staff I'm part of, said I'm the only geologist. We do have 4 biologists. We have 1 oceanographer. We have engineer. So 1, or actually 2 engineers and so on. So it's a broad range of activities we cover with hopefully enough expertise to keep our member states happy. Yeah. Coming to resources, and that's my homeland here now, because I'm a resource geologist, as Esther introduced me, right? So we basically have three defined resource types on the seabed. There are more. And you probably know, you probably have read that Japan, for example, they go for metalliferous sediments, which are not defined as a resource yet. It might be the future, who knows? So right now we deal with polymetallic manganese nodules, which is by far the most in the media, covered by the media. We do have iron, cobalt-rich ferromanganese crusts, which is iron manganese rich crusts, basically copper, again, copper, cobalt, nickel, and so on. And then there are seafloor mesosulfide deposits. All these three types occur at different locations, and they require different geological settings, which is important. So these crusts occur on seamounts, and this basically in water depth in between 800 to 1500 meters, nicely defined, which is related to the layering in the water column. It's defined by the oxygen minimum zone. Coming to this a bit later on. Nodules occur deep in the ocean, so they occur between 4,000 to 6,000 meters, right? And they, when you see the picture on the left-hand side, there are potato-shaped aggregations or concretions or precipitates, which grow twofold by metals precipitating. Metals means manganese, nickel, copper, cobalt, zinc, molybdenum, light rare earth elements, but also lithium. This is precipitated or sucked into these features, into these potato-shaped aggregations from the water column. The concentrations in the water column are pretty low, but still, over time, right? Over time, it's sucked in, but also they grow from below, which is the sediment. And the sediment is delivering these metals over time. So the growth rates are up to 4 centimeters per million years. So the larger a nodule is, the older it usually is. Right? Polymetallic mesosulfide deposits, they occur on mid-ocean ridges. And these mid-ocean ridges are the places where new oceanic crust is formed by volcanic activities. This is nature. This is Earth mantle doing it, right? And along these fractures, the magma comes up, but also the water pressure from above is sucked into the oceanic crust and is then heated up. And by this, it transforms from regular seawater, which has temperature of 1.7 degrees, a pH value of 7.8, right? So just regular seawater, it changes into a very aggressive acidic fluid. And this fluid is mobilizing metals and elements from the rocks. And then we get a nice convection cell. So because it's heated up, right, it rises back to the seabed and is precipitating these metals. And this is a process which is known for 3.7 billion years, right? There are some good examples in Sierra Leone and Liberia, for example, of these ore deposits, which formed exactly in the same way as we can observe in our days. Cobalt-rich ferromanganese crusts, as said, they grow on seamounts, and they get all the metals only from the water mass, only from the water. And because concentrations in the water are so low, they have a growth rate of 1 to 4 millimeters per million years, right? So very, very slow growth, which means the older a seamount is, the better and thicker the crust would be. Again, time is working for us. Time is always working for forming large resources, right? And you can see the metals here. So that's basically what we talk about at the moment. And also that's basically three of these minerals which you can expect in the ECOWAS region, if I can call it like this, the offshore region, right? So the when we do a world map, and that's a map where we have compiled all available bathymetric data, which means it shows the morphology of the seabed. And here's a point I really have to talk about, because what you read in the newspapers and in reports and some groups, some NGO groups, they always say, we don't know, right? We don't know. So we do have a map of the seabed, which is complete, 100%. And this comes from satellite measurements of the gravity. Because in oceans, the differences in gravity, and this can be used to model or to measure the morphology on the seabed. The resolution is key. And the resolution by these satellite measurements is better than 466 meters. So 1 point of information within a range of 466 meters, or a circle, if you want so, which means we can identify on our global seabed, right? We can identify a football stadium. So that's how good our resolution is. Towards the poles, the resolution gets higher. So at 30 degrees north and south, for example, it's 280 meters. At 60 degrees north-south, it's already 220 meters and so on. So now people seem to understand that saying we don't know anything is just wrong, right? So now they claim we don't have high resolution data. And that's true, right? So we do have, as said, the resolution I just mentioned is not enough, because we would like to have more. We want to see details, right? So any shipborne bathymetric measurements. So you sit on a ship. The ship is sending out sounding, just like whales communicate, right? And sound is traveling in the water column. It's a function of temperature in a way, which makes it a bit more complicated. But anyway, so we are basically much closer to the seabed, right? And by doing this, we get resolutions of about 90 to 100 meters. So one information point in a circle of 100 meter, not diameter. So would be 50 meter diameter, right? And that's what we can do based on ship. So it's shipborne morphology. And there are 27.3%. So just the value I looked up yesterday, right? 27.3% of our global ocean seabed is mapped at a resolution of 100 degrees. So it's good. 100 meters. We get even better resolution as soon as we send robots or autonomous vehicles, and I'm going to show you pictures afterwards, autonomous closer to the seabed, and then we can focus on small details, and then we have a resolution much better than a meter or so, right? Depends a little bit on the height where these tools are flying. So we have the technical capability for getting a very, very, very detailed picture of the seabed, but please understand and take this message out. We do have a complete map of the seabed. Now, just a side story, which is pretty interesting. So you may have read that people say we know the backside of the moon better than our seabed. I don't know. We can ask afterwards who has read this. This argument actually it stems from the late 1950s, and it was brought up by NASA when the US had their Gemini program going to the moon, right? They wanted to go to the moon, and then people got scared and say, "What? No humans in space? It's dangerous, right?" And then they came up with this argument, no, it's safe because we know the backside of the moon better than our seabed. And this argument, which is also wrong, right? I mean, this was marketing their interest, basically, right? So this is reused in 2025, right? So I think this tells a lot about our human brain, right? But it's still a wrong argument, right? So please keep this in mind. I'm always telling the story because it's pretty interesting, I think, huh? And it moves on through generations of people, huh? So I like it. Our contracted areas are sitting in the Pacific, in the Atlantic Ocean, in the Indian Ocean. Yeah, that's it. So this D here, that's the area where most exploration licenses sit for manganese nodules, polymetallic manganese nodules. And this is not because it's a nice area where the sun is always shining and so on. No, there's a saying when you do exploration for resources on land, there's a saying if you want to hunt for elephants, go to elephant country, right? Of course, we shouldn't hunt for elephant anyway, unless it's necessary, right? So, but this saying is valid for resources. So this particular area is just perfect for forming manganese nodules and to keep them alive. Because as soon as nodules get covered by sediments, they may dissolve, right? That's why. But it does not mean that nodules not occur in different locations. And the conditions which are existing in the Central Pacific here, in the CZZ, the area in between the Clarion in the north and the Clipperton to the south fracture zone in the Pacific, the conditions are not different from conditions you may find in the ECOWAS region. So keep this in mind, huh? Because it already says a lot of the potential. So the conditions are just good because there's not too much sedimentation. It's a region where not too much life exists, right? There's just not enough food for animals to be there, right? And when you transfer this latitude to the ECOWAS region, you can already guess, oh, okay, this sounds interesting, right? And it's the same with the sector E, also in the Pacific, which is the Western Pacific, same latitude, right? Interesting stuff. Then we have nodules as well. And this is just at a similar distance from the equator, but on the southern globe. It's nodules in the Indian Ocean over here, right? So yeah, it tells us about the chance finding resources. Then all these pearl-like arrangements are along mid-ocean ridges. So those are or contracts for polymetallic sulfide exploration. Same in the Indian Ocean here. And number A is actually a pending contract with Brazil. Brazil did some exploration, but they basically used the data for their application for an extension of the continental shelf. So they set up a program with their country and say, so we want to look for marine resources. And by doing this, we also gather data which may or may not allow us to apply for an extension of the continental shelf. And it did actually. So they have submitted the application, and that's why they say, well, we want to finalize our contract with ISA. That's fine. It's their decision. And if it's Brazil, they don't need an international agency anymore, right? So yeah, you just wait for the last data, and then A disappears basically. Okay, so the area, as said, has a size 54% of world ocean floors. The contractor areas under exploration are 1.47 million square kilometers, right? Which combines to 19 licenses for nodules, polymetallic nodules, 8 licenses or contracts for polymetallic sulfides, 5 for the cobalt-rich ferromanganese crusts. There are reserve areas around. This kept open for exploration by developing states only or entities. And this is area which has been pre-explored by so-called pioneer investors. And the pioneer investors were active in doing exploration before ISA actually existed, right? UNCLOS existed, but they were granted special rights to apply for their own contracts, but they also had to put other areas aside for developing countries, and there are still 0.8 million square kilometers available. So might be of interest for some of your countries, which means that the area share, right, of the contracts are 0.83%. If we put in the reserved areas, it sums up to 1.3%. So, and the world ocean share, which is not just the area, but also water masses and national jurisdiction and so on, it's 0.6%. So when you look up for in Google, so for marine mining, what you get is an impression that ISA wants to mine the entire seabed, right? Because I mean some people want to make it bigger than it is, but it's not. So we talk about 0.883% of the area. It's tiny little amount or tiny little space which is covered. Just for your information. So all activities are producing data, and all this data has to be reported to ISA. It's mandatory. It's our mandate, but also mandatory to our contractors. So it comes from, oops, going back. Anyways, yeah, I just continue. So it's mandatory, and everything which is environmental data is open, is publicly open, and you all can download the data from ISA webpage, from our database, which is called Deep Data. The ISA Action Plan for Marine Scientific Research we developed, so it deals, or the targets are long-term ocean observation and ocean health. So it lines a little bit with UN targets, right? We do have programs on assessing the biodiversity, which is called SKI. It's a name, right? And a new initiative funded by Korea is a biobank where they collect with our help and the help of contractors, but also other researchers to collect the genomes of life, basically, right? There's also a reason, because people still think that we may find potential medical or potential pharmaceuticals in marine life, which will be identified in the future. So to keep it open for potential medical uses. So there are technological innovations. So we do regular technology workshops on different topics. Last one was in Kobe, Japan, on monitoring, and the next one will be hopefully in Africa on ocean observation and technology transfer, because it's one of our mandatory jobs. ISA has to transfer technologies developed to developing countries. There's a study on the interactions between fishing and mineral resource related activities. And that's important, of course, right? Because in the water column above nodules, sulfides, crust, there might be fishing. And of course, fishermen are getting nervous as soon as you talk about mining. So there was a study where we tried to figure out who is fishing in ISA's contract areas. And also this is a technical study which can be downloaded from ISA's webpage. All spatial analysis. We do have mentoring programs, and of course we try to assess cumulative effects on exploration. Yep. Yes, right. So what is the ECOWAS perspective? You've seen this page before. So we deal with this area here, right? So let's dive into this. So when it comes to ocean water depth ranges, so I was talking about the depth of manganese nodules, right? Manganese nodules would be easy, or will be relatively easy to collect, because they lie on the seabed. You only have to pick them up only, right? You're still dealing with larger water depth. So the depth, if the depth range says anything about the potential, it says, well, there's no difference. Basically no difference in between the Central Pacific. There's a nodule belt. There are ridges which are outside national jurisdiction, but there are ridges around, there are seamounts, and so on. So that's a good sign. That's good to see. When it comes to resources, it also comes with age, right? So as I said, the older the geology is, the more mineral can be collected, right? Or the more metals can be collected. The richer the minerals should be and probably are, right? So when we look at the ECOWAS region and we compare with crustal ages, I found this nice globe here, right? You see, it looks good. It's old, right? This region has a particular age in the oceanic crust. Usually, it's the Atlantic Ocean is referred to a relatively young feature, but actually that's not true. It started on the northern hemisphere, right, to separate. So that's why you have these crustal ages of 100, what is it, 150, 160 million years, and that's good. It's good to enrich minerals, right? Uh, when compared to the prime area for manganese nodules, or which have been identified yet, it's not the only one, as I said, right? But which has been identified as a prime region for manganese nodules. When you compare the ages, your age is much older than theirs, right? So, and it's a prime area for manganese nodules. So this looks great. So coming back to polymetallic manganese nodules, and we used AI, but also existing stations actually to model what's out there in our oceans, right? Because what we see here, that's manganese nodule belt, right? So it's the Clarion-Clipperton fracture zone area, right? So with lots of activities and sampling and so on. So that's a sampling point. It's a big pile of sampling points. When we look at the ECOWAS area, right? When it comes to sampling points, which is reported, we have to be careful here, right? But there's nothing, right? So it seems, and we really would have to dig deep now and say, okay, who worked there for what? Did they ever collected manganese nodules, or was there even a program to collect manganese nodules and so on, right? But from our database, there's nothing, which does not mean that they don't exist. There were just no one was interested. And it said so latitude-wise, it's perfect setting, right? So you really wonder what's happening with these researchers, right? Why do they focus on what's known? I mean, it's easier, isn't it? But research is definitely necessary in this area, that's for sure. Same for the Indian Ocean. A big pile here, but it seems so people want to focus on what they already know, right? I think that's a human behavior. And there are not too many prospectors and saying, oh, okay, I'm just spending time and money, of course, and so on, and look elsewhere and see what I can find. So when it comes, as said, there's no sampling, but we used AI and say, okay, what's the similarities, what's the differences, and so on. And when you see here, that's the ECOWAS area. I don't know whether or not it covers. We would have to dive deeper into this and closer, right? If it's extended continental shelf, or if it's within national jurisdiction, but for sure it's a bit out. It's close, right? There are good areas for manganese nodules over here to the south as well, and so on. So that's AI. AI only uses what's available. And we're not talking about ChatGPT. There was a nice article by Cambridge University which basically destroyed ChatGPT, right? So I'm talking about real data, real information. So what we know on a global scale, we have 388 billion tons of manganese nodules. It's big. I mean, this is modeling still. We have to be careful, right? But it's huge, right? And there are trillion tons of manganese and billion tons of nickel and copper and billion tons of cobalt. So when people tell you, well, our resources are getting less and less and less and less, and we don't have anything available, so that's why we need to go to the seabed. That's not true, right? So we do have a lot on land, right? And the seabed as well. Of course, not everything ever will be mined. Of course not. Because it's not contracted and people don't want it. But still, there's huge potential. That's good to know. So we as humanity, we will not run out of manganese, copper, cobalt, and nickel, which is good, I think. That's our interest. When it comes to cobalt-rich ferromanganese crusts, sampling points look better here. As said, they grow on seamounts, right? And there are samples. And again, there's a predictive map out of AI functions or big data assessments and AI functions. And we see good area here. Yeah, in the ECOWAS region, in the wider region, right? Also with these numbers, I will share the presentation afterwards, so you can have a copy, whoever is interested in. So coming closer, and this is a nice map. I wanted to have this map. I asked my GIS colleague to produce, and this is basically the oceanographic information on the ECOWAS region, which means seabed information. So if some of you may have thought, well, we don't know our seabed so well, right? There's no data. No, that's not true. As I said, according to our satellite gravity measurements, which are publicly available and so on, we can produce these maps, right? So that it already looks very good. So what we see here on the which is reddish, right? Everything which runs north to south is a mid-Atlantic ridge, right? It's a ridge system which has polymetallic massive sulfide occurrences and potentially deposits. Everything which is also red and runs east-west, those are transform faults, which is setting the ridge aside from time to time. This has geometric reasons because we're living on a globe, right? And so on. So these east-west running fault lanes, they don't have sulfides, right? And also the mid-ocean ridge is outside the national jurisdiction of ECOWAS, which is shown here in brownish colors. Everything which is more grayish is applied extension of the continental shelf. That's what my colleague told me. So data obviously is available for us, right? So ridges are out of ECOWAS region, but sulfides form on the ridge, and then the ridge is separating, which means sulfide occurrence or a big deposit will be transported to the sides, to the east and to the west. So there might be sulfides in the ECOWAS region already, national jurisdiction or the extended zones, but they will occur under thick sediments. And this requires a different set of exploration tools, which is basically geophysics, right? Which allows us to look deeper in the seabed. So that's more difficult to do. But there are these plains, and these plains are prime regions to form and to hold manganese nodules. And there's the Cape Verde plain, the Gambia plain, Sierra Leone basin, which is also a plain, right? The Guinea plain or Guinea basin. So those basins would or could be prime areas for manganese nodules, right? And part of these plains occur actually in national jurisdiction or the extended area. And then everything which is a bit pinkish here, right? Those are seamounts. And these seamounts have crusts on top, right? Always. And as we've seen, the oceanic crust here is old, right? It's among the oldest oceanic crust occurring on our globe, right? So there's a very good, very good potential for cobalt-rich ferromanganese crusts close or within, for sure, in Cape Verde, right? But also along here and so on, and potentially closer to the continent, closer to the countries here. Good potential for cobalt-rich ferromanganese crusts. Just to let you know, cobalt-rich manganese crusts also hold about 800 ppb, which is 800 milligrams per ton of material of platinum, right? You would say, wow, this is minimal, but just, I mean, if people produce something like 2 million tons a year, it's a lot of platinum. Huh? This has a good value. So this is how the region looks like and what the potential would be. Because we talk about blue economy. So what entails blue economy? It's science, of course. It's monitoring and knowledge management, because member countries and coastal countries, they want to know what they have, right? So it entails monitoring the gain of knowledge and the management of knowledge, right? Then it offers a lot of energy sources. It's sustainable and net zero, which is geothermal from the crust, current energy, wave energy, but also, for example, what India is doing. Oh, yeah. What India is doing, they use the difference in water temperatures to run a facility to desalinate seawater for drinking purpose on their western coast, because they're running out of drinking water for the people there. So very interesting aspects. I was talking about pharmaceuticals and so on. So which is all entailing the so-called blue economy. ISA also deals with technology, what I said, and we have defined 5 different main targets when it comes to technological approaches and solutions, which is ocean observation and communication. So everything we measure, we want to get to a surface so that we can read it, so that we can use it, right? And also transfer the information from the ship onto shore, which is communication. Sometimes not that easy. Monitoring. We want to know what's happening down there when it comes to earthquake forecast, for example, when it comes to volcanic activity, so natural hazards. Also, sometimes there are submarine avalanches of thick sediment piles which are running into the oceanic basin, right? Which may disrupt cables and so on. So this requires monitoring. There's autonomy. So we increasingly use robotics, autonomous vehicles like this Hugin AUV here, which you can program, and it goes, and also automated systems. So we don't have to follow it anymore. It just measures and then eventually is coming back to the ship or to a station, docking station, and delivers data. We focus on machine learning and, I said, artificial intelligence, because we want to know what else can we get out of all the data which is existing, right? And then, of course, a very important technological approach is how would we mine nodules? How would we mine crust? How would we mine sulfides? This does not exist yet. I mean, there's some testing, but there's not a single existing mining tool which has been proven to be able, for example, to mine 10,000 tons of nodules a day to produce 3.5 million tons of manganese nodules per year to make it economically feasible, right? So this is not existing yet. So that's what I deal with, but also the energy consumption, where does it come from? And then, of course, the metal processing. Mining nodules is not enough. We want to have the nickel, copper, cobalt, manganese, and in the crust for platinum. We want to get it out as a metal, right? Which is metal processing, which is again always considered the most the most expensive part of mining, right? So getting the stuff out of the ground is relatively easy and does not create too high costs, even on the seabed, but then getting the metals out is a bit more challenging. So, and of course, I was talking about monitoring. So if there are activities on the seabed, like for exploration or exploitation, to exploration is happening now. And of course, contractors, as well as us, we want to know what the contractors are doing, and the contractors want to know what the tools are doing. Are they working properly, right? Are they measuring the right data? They're programmed to do so, and so on. So this requires monitoring, and also we want to know, we as ISA, but also contractor want to know what is the water column, how is the water column composed, and so on. And this entails environmental monitoring with the tools we can put on the ground, and then it's stable, and then collect every year or so, right? Or within 3 months. Or we use mobile instruments, which are wave gliders. They basically stay on surface, but they can be used to measure the deeper water column. There are other sources of the runs back and forth. There are robots and so on. So now we're talking about data access, and the data access is not so easy. So for communication in the water column, usually what's used is sound, right? Just like whales. Actually, whales don't sing. Some people think they sing. No, they communicate, they speak, right? So, and as whales or marine mammals, they make noise to communicate, just like us, right? And we also use this sounding, for communication of data, but it's limited in size. So we cannot transport huge amount of data. That's why there's also optical communication by lasers. You can load a lot of data on laser systems, right? But these lasers have to be undisrupted. So you have to go very, 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 very close to read the information which is transported by light, in a way. But light can transport much, much higher amounts of data than sounding. And then people could also think about cable systems. This would be something, for example, in the ECOWAS region, because it's not too far from land, right? That people could think about putting in cables. Then you have fiber optic cables, which is fast, right? So you get information in real time, basically, right? So this might be a solution. Okay. Then I really like this idea of using offshore geothermal energy, because we know along these mid-ocean ridges, and you've seen these pinkish line there, right? We do have magma which comes out of the ground with 1,200 degrees Celsius, hot. The crust is hot, right? Much hotter than any geothermal energy. Not any. I mean, there are volcanic systems in Iceland, New Zealand, in Kenya as well, along the East African Graben Rift. But it's high temperature. So there are models and there are companies they are interested in, but they have not set up a testing facility, which would be necessary now. And the idea is actually not to go for the hot parts, because it's also dangerous for the piping and so on, but go a bit further away and then use the energy to create hydrogen as an energy system, right? Or ammonia for running ships, because as we want to decarbonize our economy, right? So ammonia would be one possibility, or hydrogen. So not to transport heat onto land, but to create something which can create heat on land when it's transported on land, or just a docking station for ships, like a gas station. Ships are coming by, loading ammonia, and then move on, right? It's a very interesting concept. So a new concept, technology-wise, are also, I'm just talking about it, are also USVs, unmanned ships and drones. The drones are, I mean, they're heavily used in military, as we see every day, right? At least in Europe. But these ships can be out at sea for up to 30 days without a single person on the ships. And they offer communication facilities on surface, but they have these garages for tools. and then tools are running out of these garages, like in robot or these autonomous vehicles, right? If they do their job, they check for pipelines and so on, and repair pipelines, and then they come back and deliver the information. And that's not future, right? It's not Star Wars or so. It's existing. This picture I just saw, it was running. You can see it afterwards. It's built by MCS, which is a company being busy in the oil and gas industry. And if we have participants here from Nigeria, I'm very sure that you know the company or you know similar systems which are used by the oil and gas industry, right? So yeah, everything ISA is doing, and as soon as it comes into mining, or which is covering more than 10,000 square meters, not kilometers, meters. And that's not too big, right? It's about 300 by 300 meters, right? This requires an environmental impact statement, which means the contractor who wants to do these jobs has to collect data and describe the habitats, the biodiversity, the water column, including temperature, salinity, oxygen saturation, blah, 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 all these different aspects, right? And also geology and so on, and report in these environmental impact statements. And there's a guidance, so it's mandatory to do so. And we tell the contractors this is how you need to do it. There's a guidance on necessary baseline studies for monitoring and the reporting and so on. And then there's an EIS, environmental impact statement review process. And as of September, last month or this month is the same, right? We do have 6 contractors, and they have submitted an EIS because they wanted to test tools which they may use for potential future mining, right? And all this is public. You can download from ISA webpage. There's always a public stakeholder consultation. It's mandatory, right? So everyone, all of us can submit questions. We as secretariat, we do anyways, right? But if there are other questions, they can submit it, and the contractor has to deal with them. So as said, up to now 6. So we had in 2018 2 of these. They tested a tool which was developed by one of our contractors, GSR in Belgium. Was tested in 2 separate contract areas, and this required 2 separate EIS, environmental impact statement, of course. And then in 2020 was India, Nauru, Beijing Pioneer, and China Minmetals. They submitted last year, and they will do the testing at the end of this year, basically. So there's transparency. Different from what's always reported about ISA, everything is hidden, no one knows, and so on. That's actually absolutely not true. We always refer to our webpage. The data is open when it comes to environmental data, not the resource data, of course, because that's only disclosed by the contractor, right? Because as soon as you disclose we have that many metals, then metal prices are dropping down, of course, right? So that's what you don't want, and that's an industry-based information, right? So, but everything which is described in environment is publicly open and can be, can be assessed. So this is my presentation. I hope you found it interesting, and just let me know if you have questions now or later by email or so, whenever. Thank you for your attention.
Thank you so much. It was really an insightful presentation, and I was fascinated by the fact that aside the exploration and exploitation, ISA is also interested in ensuring environmental protection. So it's really a good thing to note. I don't know if anyone has any question. You can unmute yourself and ask your question, or you can just drop it in the chat box. Okay.
Yeah, I have a question. Oh, well,
Okay.
I have a few questions. Thank you, Oish, for this presentation.
Welcome.
Quite exhaustive. And thank you for bringing our backyard to us.
Yeah.
The
Yeah.
map on ECOWAS
Yeah.
deep seabed. It was, I must confess, that's the first time I'm saying that.
Mhm.
So, yeah, thank you. Thank you very much. Yeah, you said a few quite a number of interesting things. I'm not going to drag you into the politics of it. I'm going to be, because I know whatever
Yeah.
you say may be misinterpreted to say, oh, the ISA said this, so I'm not
Yeah.
going to drag you into
Yeah.
the politics.
Yeah.
But just to add some on the
Yeah.
scientific aspect, because it seems as if you contradicted science
Yeah.
when you said that it used to be said that we know the back of the moon better than the deep seabed.
Mm.
Because now I know that when you research the science, they tell you that the sea is still being discovered. Only a tiny portion of the sea is known. Are you saying that's not true anymore?
No, actually, so first, whenever you hear this argument, so little is known, that's not true. Don't believe it. It's not true. So as said, we know the morphology. We know all the different water masses. There are up to 7 water masses in an ocean. It's not one water, right? So there are different water masses. They flow in different directions. They have internal waves. So very, very complex. But that's all known. There are 32 million water stations in our oceans, right? So not 20,000 or so, right? It's dramatic. No, should say dramatic, but there's so much information. And just by repeating by some groups and saying, we don't know, we don't know, then the answer would be you don't know, right? But you can figure it out, and we can help you, right? So that's the thing. It's a kind of an repeating argument that's because we don't know, right? No one knows. And there was a nice discussion in a meeting in between a marine biologist, because it's basically marine biologists. They say, we found a new species, new species, new species, right? There's a big discussion about how many species can we actually expect coming from our oceans. Interesting question, isn't it? I mean, scientists like these things, right? and And when you look it up, there's not an easy answer, and that's a kind of surprising, right? So the numbers range from 700,000 to 2.2 million. And because I do have a scientific background, I'm not a biologist, but I'm geologist. And if when you read these numbers, say, come on, guys, you can do better, right? So there's a big discussion. What we know is there are 250,000 identified species. If we take the 700,000, we already know 250,000. If we take the 2.2 million, still, we know 250,000 marine species. Knowing also means that biologists always want to give things a name. Fair. But that's a thing I'm always saying, well, this was what geologists did about 100 years ago. So they found a rock, they described the rock and say, I named this rock this, right? I mean, we are far beyond this now. We do analysis and stuff, right? And that's also possible in the biology sector in identifying the genetic characteristics, which is easy. You don't even have to have a sample. You can sample water, right? And then you have everything, all the information. But still, if you do this, you only have a genetic sequence and not a name, right? And if you are only interested in naming things, of course, you are frustrated. And you say, that's not enough. That's not good. Yeah, that's the thing. So what ISA is doing, actually, I was mentioning this biobank, which is a genetic approach. Our contractors are mapping the seabed as well, but as I said, because the contract areas are only 0.66% of the global oceans, but still we ask them to also map the ways into the working areas. So by this, in building up more high resolution data for the morphology. And yeah, So we try to promote the gain of knowledge wherever we can. So let's hope that everyone does. Was it answering your question? I hope.
Yes, you did. I have one more question.
Yeah.
Why, for instance, in the CCC zone, or
Yeah.
CC zone, we
Yeah.
see a lot of there seems to be a lot of interest in that zone compared to some other zone, like the Atlantic, the Atlantic side where we are. There don't seem to be too much interest in. Is it that there's no interest, or there has been no attempt to explore to see what's there, or it's just that they may not be commercially viable, so to say, because there's one thing to have resources, to have minerals, the other thing for it to be commercially viable. So is there a reason, for instance, why there seems to be more interest in certain areas like the Indian Ocean and all of that, but there isn't much interest in certain others?
Yeah. As said, the potential, there are large areas with a similar potential, just like your region, the ECOWAS region, within or also just outside the national jurisdiction or the extension areas. Because the conditions are similar. So we have oligotrophic conditions, which means we don't get too much food or substances which are used by the animals, right? And that's why there's not too much life. Not too much life in the water column means not too much sediments. And in the CCZ, just like in your region, it's just enough sediment to supply material for forming these nodules, right? But not too much to bury them, because burying them would mean they dissolve, or they have a potential to dissolve again, but also they are more difficult to find, right? So when it comes to the potential, because the conditions are they are very similar. The reason, I don't know how much time you have, very interesting story actually. The reason why everything is so packed in the Pacific, so packed, was that the first activity on nodules was in the same region. And then of course, I mean that's what we do. So right, so someone is coming to me with a nice, I don't know, with a nice breadfruit from the market and say, wow, that's a nice breadfruit. Where did you get it from? And then you go as well, right? It's the same with these nodules. People say, we found nodules, high in metals, right? And then you go as well if you're interested in resources. So it's more our human behavior than logic. And you can actually find the same on land, right? So by far the most exploration, more than 90% of exploration on land goes to, or is actually brownfield, it's called, which means you see the head frame of the mine from your working area, right? So people are hesitant to go to greenfield exploration, which means there's nothing known, there never was a mine, right? But still, it's high potential. So it's a cost factor, of course, right? So when you know that something is there, it's easier to raise funding. You can see a faster success, I guess, right? Because you know it's there. So that's the main reason. But don't think that the ECOWAS region, wider region, has no potential. No, that's not true. The same potential as the CCZ, right?
Okay, thank you so much. I'll just take you back to the point on internship. You said something about ISA and internship opportunity. While your presentation was going on, I actually received an email from ISA, a rejection email, because I applied for the African Academy for Deep Sea Diplomacy.
Yeah, okay, yeah. And
Okay,
was successful, I
so
hope.
no. It was a
No,
rejection email,
but
actually.
try again. Try again. Don't be
Definitely.
frustrated. There will be a chance. Yeah.
Okay. Well, then I want to ask question about internship opportunities because we have a good number of students here. Yes. How do we assess these opportunities? Yeah. How can we take advantage of ISA opportunities, internship opportunities for students and also for people trying to build a career in the blue economy?
Yeah. So there's always a good opportunity for an internship if you bring your own money, which of course is not possible. I know. Right? But we've had interns coming from Jamaica because it's easy for them. It's cheap for them. Internships are usually not paid, which means we then declare it as an expert deployment. Of course, you're experts. Of course, we know, right? And expert deployments, there are ways to organize. You may know that there's a partnership fund at ISA, which is actually meant to be used for in parts, right, for expert deployments. It's the thing. Also, if I don't have a good understanding on how ECOWAS is organized, but for example, if there's a letter by ECOWAS and say we want to be more or we want to be closer to ISA because we are member states, right? And we suggest deployment of our national experts at ISA. What are the funding opportunities, right? So then it comes to ISA, and then ISA will think about it. And I'm very sure that it's considered very positive. Because that's exactly what ISA is supposed to do, right? According to UNCLOS. Technology transfer, capacity building, and so on and so on. So this would be good. Also, what we establish with other partners is a memorandum of understanding. So if ECOWAS has a bureau or so, right, which can be contacted and say, well, just consider a meeting with a more high-level meeting, right, with our Secretary General, and say, well, we would like to be closer to you, right? What about MOU? And then define some projects in this MOU, saying, well, this is capacity building. We want to send our national experts to ISA and require funding for this. Of course, you do, right? There are ways, and it's not. If I'm saying this, it's not like, oh, it takes another 5 years or so. I don't think so. Because that's really in the heart of our Madam Secretary General. That's what she said, right? Saying she wants to have more countries involved and to have them closer to ISA, right? To deliver what we are supposed to deliver, right? So yeah, this would be so. A letter in the beginning would be good.
Okay. Thank you.
You're welcome.
Someone has a question. Kingsley, you can unmute yourself. Kingsley Equerry, if you can hear me, you can just unmute yourself and speak.
I think there's a question in the chat box as well. If we just take those two questions and call it a day, so I would keep for this too long.
I'm not sure I can see the question. I dropped off, but if you can assist, sir.
Okay, it says, for clarity's sake, when the ISA is addressing different bodies of waters, I know the term sea is used, but doesn't it include the oceans and the rivers? Is the exploration only on the sea water bodies, or is just a terminology to address all major water bodies?
That's a very interesting question and very important question, right? So I mean, there's always confusion about the term. So if you ask me, a seabed, I was That's not a proper term, but this was introduced back in 1952, right? For example, and of course, it was never changed. So the sea actually means oceans, right? Oceans, and it's only oceans. It's not lakes, it's not rivers or so, because this is under national jurisdiction. And also the continental shelf. I didn't show a picture on how the continental shelf is defined, which is also legally defined. Geologists would define it in a different way. Huh? So we talk about ocean, and ocean waters are different. For example, you can imagine if we go to the polar regions and an iceberg is melting, this creates very dense, less saline water, right? And because it's also cold, it flows directly to the ground onto the seabed, and then it's transported on the seabed in a direction which follows morphology, right? And there's warmer water on top, which means the temperature of this Arctic water or polar water is changing as well, and the conditions, how it flows, how it mixes with the other water, and so on, is so different. So it's very complex. Just keep in mind that we don't have one water mass. No, we do have many, up to 7 different water masses in our oceans. So is it? So when you see the seabed or seawater bodies, it's considered ocean only. No lakes, no rivers.
Okay, thank you. The second question. So you can take the second question.
Second question. Okay, no, I've answered that. It was just asking if it's possible to have the lecture side. So I've answered that.
Yeah.
So
maybe can I just give the information? So I would create a PDF and I send it to you, okay? And then you can share. Yeah.
thank you.
Would it be okay? Yeah, sure. No
Thank
problem.
you. Thank you.
Yeah.
Thank you. Thank you so much.
You're welcome, of course.
Okay. I will invite my colleague Chukwunazoku for the vote of thanks on behalf of the Center for Community and Oceanic Law.
So, hello, sir. Good evening. Just to say thank you very much for the very informative session. I mean, I feel like most of us here before now didn't have as much information about our seabed as we have after receiving all you have said, especially Mr. Amos rightly pointed out, Professor Amos rightly pointed out like our backyard was. So we are very grateful. Thank you for the information, especially concerning the internships and everything else we have learned this evening. We're very grateful on behalf of the center and every participant. We would like to say thank you, and we look forward to getting your slides because much of what we learned has been a lot to digest. So by the time we go over the PDF you will send across to help us retain all the information that we have gotten this evening. Thank you very much, sir.
Thank you very much. It was a pleasure.
Thank you.